We're back again today, and I know it looks like deja vu, but it's not. It is a different sprint. It is the week of the sprints. I do know I planned it. But yeah, we're just making really, really focused efforts on practicing with subtraction. And we're going to actually complete this sprint from lesson 35 today, or part A. We'll do part B later. Yeah, we'll do it together. Don't worry about it. So, Starry Night book, practice. This is where we'll find our sprint. It reads, write the missing number for each subtraction sentence. Pay attention to the equal sign. Now, these are not all -0 and -1 this time, or =0 and =1. So you have to pay attention to what's going on. Most of them will be, but not all of them. Once you think about what's happening, it is on page number 53. So on page number in this book on page number 53. I'm gonna go ahead and get 1 minute on the clock. And remember, you're only competing with you. You're your only competition. You're only racing with yourself. It's okay if you only get to 8 and they're right. That's amazing. I'd rather you get through 8 and be all right than get through 30 and have no clue what to talk about. So we're gonna go ahead and now that we've talked about it, we're gonna put time on the clock. On your mark, get set, go. All right, we know what that means. It means time is up, which means you've done your best. We're going to go ahead and check our work. So, yes, we're not doing any more. We're checking our work. And if you get it right, you get a check and a little tiny yes. So, come on. Yes, so this one we're writing the missing number for each subtraction sentence. Still paying attention to the equal sign, location of the equal sign. So, 0, 0, 1, 0, 1, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Top of column 2. 10, 9, 8, 6, 5, 6, 9, 9, 10, 7, 7, 9, 8, 8, 6. Excellent work, guys. Yep, you're writing the number correct at the top in the little starburst. And we're going to go on ahead and continue on with our lesson for the day. All right, yes. So it is our application problem. You did wonderful on that sprint. We have our Learn book. It is the next, well, no, it's like the next page. It is page number 239. And I'm going to read it, step out the frame. We're going to work on it for 3 minutes, and then we will resume and work together. There are 10 beads on the floor. There is the same number of red beads as white beads. A student picks up the white beads. How many beads are still on the floor? All right, well, let me step up so you can get a clear shot. All right, so let's see what we have here. It says there are 10 beads on the floor and the same number of red beads as white beads. A student picks up the white beads. How many beads are still on the floor? Well, we know we have the information that what is our whole? It is 10. Our whole is 10. And there are beads on the floor, red and white. So for right now, let's put R for red and W for white. What we've been told is that it's the same number of red beads as white beads. So let's make a group. Red bead, white bead, red bead, put my hand so you see it, white bead. Let's see real good. Red bead, white bead, red bead, white bead, red bead, white bead. So are you seeing what I'm seeing? It's doubles. Yes, it is doubles. So if we're saying that there's the same number, that means our parts need to match. And it tells us that a student picks up the white beads. Well, we've just established that there were 5 white beads. So 10 beads on the floor minus 5 white beads is equal to 5 red beads. 5 red beads. There are 5 more beads on the floor, and they are red. How many beads are still on the floor? 5 beads are still on the floor. This is an example of applying our doubles, because remember with doubles, your 2 parts need to have the same value. Each part is the same. They match each other to complete your whole. All right, good. So speaking of doubles, not so much on doubles, but speaking of wholes of 10, that's what we're looking at today. We are looking at subtraction problems with the whole of 10. So you got your bracelet. Let's just stretch it out so we can see it better. I'm going to unwind mine. If you can unwind yours and not lose your beads, do that. But if you can't, don't worry about that step. It's okay. I don't want you to get poked, and I definitely don't want you to lose your beads because there are no more. All right, here is my 10 beads. 10 being my whole. So if 10 is my whole, that means I can manipulate this sum. Yep, I can manipulate this whole, knowing my partners to make 10. If I have 10 minus 1, I know I'm left with 9. If I have 10 minus 2, I know the other part is 8. 10 minus 3, I'm left with 7. 10 minus 4, I'm left with 6. 10 minus 5, I'm left with 5. And so on and so forth. What's happening here is we're taking our same information of 10 is the whole, 10 is still the whole, but instead of looking for the 2 parts, we are taking the whole and subtracting 1 part to find the missing part. So let's do some practice in our book. This goes on page number 149 out of your Succeed homework book. Remember the one with the picture of the bedroom? Yes, and this is all about ways to make 10. This is all about subtracting, knowing our ways to make 10. So we know 1 and 9 is 10, 2 and 8, 3 and 7, 4 and 6, 5 and 5, 6 and 4, 7 and 3, 8 and 2, 9 and 1, and 10 and 0. And in knowing that, remember, if that's too much for you to think it through out in your brain, that's fine. Use your counters, use your bracelet. We can see what's happening. So let's try with 10 minus 2 is equal to 1. Let's start with our number bond because this is what we're most familiar with. So we know our whole is 10. The known part is 2. Well, if my whole is 10 and I know I have 2, what is left? Well, let's see. So we can use our counters or our bracelet. So here's my bracelet. I know I have 2. How many are left? 8. My missing part is 8. 8 and 2 makes 10. We know this to be true. So 10 minus 2 equals 8. What is the other subtraction sentence we get from this number bond? If 10 minus 2 is 8, so 10 minus 2 is 8, then 10 minus 8 is 2. Okay, let's try another one. We're going to start with our number bonds because it's what we're most familiar with. Putting in the pieces that we know. We know that 10 is our whole. We know that 9 is a known part. Well, how many? What's the other part? If 9 is one of our parts, if 9 is a part and our whole is 10, what's the other part? How many fingers are down? One little pinky. Yep. So that means 10 minus 1 is equal to 9. And if 10 minus 1 is equal to 9, that means that 10 minus 9 is equal to 1 is also true because they're produced from the same number bond. All right, let's try another one. 10 minus blank is equal to 6. Again, with our whole of 10, our known part is 6. Notice I'm putting the known part in the top each time, even though it's not positioned the same each time. It's for us to see going from the known to the unknown. So 10 with a known part is 6. Let's show you with the counters real quick. So I know, well, if I don't drop them, I know I have 10 counters. I know this is a set of 10 because only 10 were in the bag. That's how they were given to me, 10 counters. And if I take away my known part 6, apparently I'm dropping them on the floor. 1, 2, 3, 4, 5, 6. I'm left with the rest of my group of 10. Whoop, if I don't drop them. So remember, we were taking 10 minus 6, because that's our known part, and we're left with 4. We are left with 4. So 4 is the missing part. 6 and 4 make 10, which means 10 minus 4 is equal to 6. And if 10 minus 4 equals 6, then 10 minus 6 equals 4. Is equal to 4. Yep, this time we're going to do a couple more, and we turned the number bond because, well, I want to make sure, no, we didn't turn the number bond. What did we do? We just stacked it differently. We put them beside the number bond. Sorry, guys. I will see a double, I guess. All right, so we're still working with our whole of 10. Our known part is 1. Hey, wait a minute. This looks familiar. This number bond is the same as this number bond. Notice, it's the same parts, which means that 9 is our missing part in this instance, and 10 minus 9 is equal to 1, which we already figured out to be true here, which also means that this must be true as well. 10 minus 1 is equal to 9. And for our last one, the last one, we are still dealing with 10 as our whole. This time our known part is 5. I want you to take a look at how this problem is written. It is written as part equals whole minus part. And our known part we said was what? 5. Our known part is 5. We've talked this before. That's our doubles conversation. If we start with 10, we know 5. We're left with 5. That's talking about that's doubles. That's taking away from the 5 groups to make it easier problem. We're left with 5. So that means 5 is equal to 10 minus 5. Or 10 minus 5 is equal to 5. Our missing part here is 5. Okay. And this all goes back to those ways to make 10. Ways to make 10. We started with addition, and now we're looking at those same number bonds, but we're giving them the subtraction treatment. It is the exact same number bonds for the ways to make 10, only now we're subtracting with them. And now you can do some work with this by yourself. All of this is wholes of 10. Every problem is wholes of 10 because that's what we're working on today. And it starts on page 241 in your Learn book. You'll work on it for about 10 minutes. If I don't drop all the counters. You'll work on it in your Learn book for about 10 minutes. When you're done, you'll be able to access your exit ticket. And this is the part that you turn in to me via Nearpod and Canvas. It does say fill in the missing part, draw a math picture if needed. So a picture is not required. Write one if you need it. Write 2 matching subtraction sentences. So with this one number bond, you can write 2 subtraction sentences. With this one number bond, you can write 2 subtraction sentences. With this one number bond, you can write 2 subtraction sentences. And that's what I want to see. So remember, today our objective was subtracting when the whole is 10. And if you have any questions, let me know.